and performance. And then, there are a lot of legacy integrations and third-party integrations that we provide. So whatever dependencies are there that can be taken care of, automation of CI/CD pipelines, decentralized governance, storage, etc. So this was a brief about Zeeve. Now coming to tokenization. So there's no doubt about that NFTs, when started 2 years back, starting with collectibles and some of the digital assets, now has expanded beyond collectibles and moved to real world assets. Yeah, still there are only few platforms and limited use cases that are being tried out, and that's because of the regulatory concerns. Once more regulations and compliances are in place, I think we'll see this market growing rapidly and immensely. Because as far as the benefits of real world asset tokenization is concerned, it's very clear. Whether it be improving the settlement cycle or backend infrastructure, cross-border liquidity, so making it much easier for retail investors to participate whenever we talk about fractionalized assets and so on and so forth. I'm sure there's a very a lineup of seasoned entrepreneurs and startups who are going to talk about various use cases and various industries where real-world asset tokenization is taking place. So as per one of the BCG report, the tokenized real-world assets could be almost $16 trillion worth of market by 2030, which is huge. And still, I believe that, as the regulatory landscape improves in next coming years, we are going to start seeing pretty much tokenization touch upon every industry. So now coming to the topic on when you are building a tokenization platform. So there are various options today. One option is that there are some SaaS platforms which are providing tokenization as a service. And at the same time, there are quite a few enterprises and other native Web3 startups who are launching their own tokenization platform. So while choosing which tokenization, like which protocol the tokenization platform needs to be built in, so there are various criteria that becomes very important. So I've basically categorized them into 5 distinct categories. One is scalability and throughput. So of course, starting with Bitcoin, Ethereum, we are seeing scalability has been a challenge in the blockchain space. And then with newer methods like layer 2s coming in, app chains coming in, and sharding, various other pieces are coming in to improve the scalability part of it. So one important consideration is, because when you launch a tokenization platform, depending on the asset type, the number of users and the transactions can grow massively over a period of time. So it's very important that the transaction throughput, the network capability as to how it can scale as the user and transaction volumes are going to scale. So this becomes very important to take care of that. And then, we also need instant finality or near instant finality at the same time, large transaction throughput. So, and that should be able to modify or configure as the use case moves on. The second is security and consensus. Again, one of the most important criteria is that the underlying blockchain or your own custom blockchain should be sufficiently decentralized. And because the whole promise of security is based on this decentralization. As the protocol gets more and more validators who are validating on the chain, we see that there's a sufficient decentralization, and there are no chances of centralizing the chain and defeating the whole purpose of having a decentralized ledger. And then consensus mechanism again becomes very important, especially from energy efficiency perspective. And again, how how much participation is allowed as per the consensus. So sometimes, we see that there are quite a few chains where they have proof of stake, but there is a very strict onboarding of validators, and only limited validators are there who are running the chain. So that again, pretty much, is, I would say, is not sufficiently decentralized. So one is the consensus mechanism itself, but at the same time, how that consensus has been put in place. Can anyone become a validator on a POS blockchain, or does it require a lengthy or very tenuous onboarding process. And then what kind of security and privacy options? So when we talk about enterprise adoption of blockchain, one of the use case, which is tokenization of real world assets, again, a lot of access control, security, privacy, these kinds of considerations become very important. Third is smart contracts and flexibility. So again, the minimum that is expected, because when we talk about tokenization, we are talking about different kind of business logic. So starting with minting of tokens, and there are various standards depending on asset class. You may choose to have different token standards that are there out there. And then, you require other pieces like decentralized identity or decentralized oracles. And then, if let's say an underlying asset has got some future cash flows, and those cash flows need to be distributed among the token holders, there would be a distribution contract, yield contract, and then the whole redemption workflow may involve again some smart contracts. So one, the a proper smart contract functionality should be available, but at the same time, more complex smart contracts can be written. So the choice of languages, today, as we know, Solidity is the major programming language which is being used to code smart contracts on all the EVM chains. And then Rust is also picking up, touching upon Solana or Polkadot ecosystem. Availability of developers depend on how popular the smart contract language has been, or how long it has been in the market. And then, different other infrastructure components, like, availability of decentralized oracles or connectivity with other integrations that we want to do with the external systems. The fourth is interoperability and integration. Now, interoperability, especially when we talk about tokenization, that becomes very important. Otherwise, lack of interoperability impacts the availability of liquidity to a large extent. And we want the assets to be cross-chain, so that even if the tokens have been minted on one chain, they can be easily migrated to other blockchains within the ecosystem or outside the ecosystem. So interoperability becomes very important. And there are various means today. We are seeing, messaging protocol in the Polkadot ecosystem to IBC, which is being used by Cosmos, and there are cross-chain bridges and various other methods. So of course, more consideration needs to be given to what are the different interoperability options, what are the different, and how secure those options are, how easy they are to integrate and work on that, and what kind of blockchains they support, what is the extent of interoperability as we talk about the overall larger ecosystem. And then, ecosystem support is basically to check the longevity or the health of the network, that how large the developer, and this is especially true for public blockchains. If you are deploying on a public blockchain, that how large the developer community is, how frequent the updates are, what kind of partnership ecosystem they have. And again, partnership from a perspective of different infrastructure, because if you're building a tokenization platform, it may be that rather than building your own decentralized identity protocol, you can use one of the ecosystem player who has been providing this kind of component. Similarly, there are various other components, like you can use Chainlink for decentralized Oracle and so on and so forth. And then, of course, there needs to be a active development which is happening in the ecosystem. So there are frequent updates that are happening. There's a larger set of contributors who are working, who are contributing to the code, finding issues, fixing it, and so on and so forth. And then, of course, when we talk about, there are various other considerations in terms of protocol, like what kind of governance structure they have, what kind of token economics they have. Again, to see that, because once we choose a protocol, migration is a difficult exercise. It's intensive exercise, especially when we want to migrate all the data, the smart contract logic, the state. So of course, it becomes important to choose the right protocol, right architecture from the very start. So these were some of the different features which needs to be considered while selecting, which protocols are ideal to choose while building your tokenization
Ravi, sorry to interrupt you. Are you sharing anything? Not seeing your screen.
Yep. Let me just reshare.
That'll be great. I'll stop my share.
Can you see my screen now?
Yes, we can, Ravi.
Okay. So the second area is that choosing the right blockchain architecture. So there are various options today, and I'll cover three major options that are available today. So one is deploying on an existing layer one, layer two blockchains. And this, I think, is the most common way today, especially when somebody's starting up. It becomes easy. And then most of the blockchain as a service platforms providing tokenization as a are also using this method. So where you build your contracts, you build your decentralized app, and you choose one of the layer one and layer two, and you deploy your platform on that. So there are various popular, whether it be Ethereum, Avalanche, Polygon, Solana, Algorand, Near, and various other protocols are there, which are supporting even complex smart contracts to various infrastructure components. And then there are some tokenization specific, very much focused on tokenization, targeting tokenization, providing some essential components, like, for example, DCOM or provenance blockchain or Corium. Corium provides smart assets. So there are ready contracts that can be leveraged rather than rewriting and writing contracts every time, getting it audited. So there are pre-audited smart contracts that can be used with minimal customization, etc. But then if you talk about, there are various challenges when we talk about layer one, layer two. One, you share the resources with other users who are deploying on these chains. So once the platform grows, the users and transactions grows, and the gas fee becomes unpredictable. And since you are sharing, there may be congestion, may be impacting the performance of your app. So these are some of the challenges that happens. The benefit of going with this method is that there's a minimal infrastructure which is required. You just simply requires some shared APIs or a dedicated node to connect with different blockchains, maybe data indexing protocol to query the data. But most of these services are today available as shared or dedicated by various infrastructure platforms, including Zeeve. And then another downside for this method is the limited control, because you have control on your app and the smart contracts, but then beyond that, you do not have control on any other configurations that may be important from, let's say, privacy or compliances, or any kind of custom configuration that may be required for managing the performance, scalability aspect. So the second option or the third option are basically launching your own blockchain. And launching your own blockchain has got two different options today. One is you can use a blockchain framework, and you can spin off your own blockchain. So we have two prominent I've covered here. One is Substrate, and the second is Cosmos SDK. And there are quite a few hundreds of chains which have been built using Substrate and Cosmos SDK. And I'm talking about which are in production right now. So it's a very solid ecosystem. So there are a lot of modular tools. You can quickly spin off your own blockchain. You have full control over how to configure, customize, and but the thing is that one of the downside of using a framework is that you need to go extra length in bringing decentralization to it. So you need to bring in validators, a set of validators who are going to validate on the chain. So that means that there are some non-core activities which can distract you from the core business, and you need to focus on rest of the other pieces. And there may be a native token which may require its own management, designing the token economics, etc. So that becomes important when you are launching your own blockchain. So these frameworks make it very easy, because all the necessary components are there. There is proper documentation. There's a proper developer support, community support. So you can build your blockchain. You can take help from different providers who are helping spin off these blockchains. But yeah, it's like launching your own blockchain. So there are various other pieces that needs to be done. And that's where I believe combining these two app chains is the third option, which has come up as a very interesting option in last 1 year. And today we are seeing more and more blockchains are launching their own app chain infrastructure. So what exactly are the app chains? So app chains are application specific blockchains. So you want to have your own blockchain, but at the same time, you do not want to get into the pain of getting your own validators, bringing decentralization, managing security, and rest of the pieces. But at the same time, you want to have control over the configurations. You don't want to share resources. You want dedicated resources so that there's a predictability on gas fee, performance, etc. So that's where the concept of application-specific blockchains came in. And some of the leading players in this space are Polygon Supernets. Polygon recently launched ZK Supernets, and then Avalanche subnets and DCOM subnets. So, and there, as I mentioned, other blockchains like whether it be Tezos or Near, or we are seeing optimistic rollups and ZK rollups. So various other players have now come up with their own app chains, and the whole idea is that you get your own custom blockchain. It's application specific, and you're leasing the security and decentralization chain. So that's how the app chain work. That you have your custom blockchain, but the main chain validators, like in the case of Avalanche, the main chain validators are validating on your subnet. So that way you are leasing security and decentralization from the main chain, and still you are running your own blockchain. And within that, you have all different kind of configurations. It can be a private chain to a semi-public to a completely public chain, depending on the kind of configurations you want to do. So this is basically, the various comparisons. Just to summarize what we just talked about. So as I mentioned, layer 1, layer 2 blockchains, they are the fundamental base level chains where you can deploy your dApps, you can deploy your smart contracts. And then, from a security perspective, they have their own consensus mechanism, independent operations. You don't need to worry about the decentralization or security aspect of it. Just from a consideration perspective, it needs to be, if you see any popular blockchains, they have hundreds or thousands of validators today. They are enough or sufficiently decentralized and keeping on adding more and more validators. On the scalability side, yes, the scalability becomes limited when we talk about layer 1, layer 2, because the resources are being shared with other users. So with layer 1 like Ethereum, we have seen congestion issues, and then layer 2 came in. But as the layer 2 also expands, like Polygon became large, so of course congestion issues start coming in with the different layer 2s also. Gas fee is unpredictable, depends on the congestion on the network. All the transactions are happening on chain in the case of layer 1. So gas fee becomes a challenge at times. And there's a limited interoperability with other chains. Now, more and more layer 1 and layer 2 chains are bringing some native interoperability that rather than using cross-chain bridges, which can be exploited, which a lot of security hacks have happened in the recent last 2 years. From an ecosystem perspective, if you see any popular blockchains, they have a robust developer and partnership ecosystem, various EVM chains, or substrate chains like Polkadot, etc., has got a very sound and robust ecosystem. Examples being Ethereum, Polygon POS, Avalanche, Solana, Tezos, DCOM, and so on and so forth. And then the second is the custom blockchain. So as I mentioned, it's like there's a main chain. So if you see Cosmos or you see Polkadot being a main chain, like a hub, so that's a hub chain, and then you can create your own blockchain using Cosmos SDK or Substrate, and you can make it as a parachain to the Polkadot ecosystem, or you can connect with the main Cosmos chain. So you are interoperable with other chains, formed using the same underlying framework, and at the same time you are connected, interoperable with the main chain. As far as security and decentralization is concerned, again, as a custom blockchain, you need to bring in the set of validators and ensure that there's a sufficient decentralization. So that onus falls on the one who is building the custom blockchain. Scalability is not an issue because here you are not sharing resources. You have your own dedicated resources. So it's sufficiently scalable, and the performance, etc., can be easily managed and controlled. Same goes for gas fee. You define your own gas fee mechanism depending on the implementation, and at the same time you have a predictable control over it. And then ecosystem is something that the one needs to drive the ecosystem because it's a custom blockchain. So of course every blockchain, like some of the custom blockchains we have seen, like Corium, Provenance. Corium is built on Cosmos SDK. So they need to build their own ecosystem. Examples are Substrate Chains, Cosmos SDK, two large frameworks today. And then there are various few frameworks which are coming in. These are the two most popular blockchain frameworks that are being used to spin off custom blockchains. And then, the third piece we discussed about the app chain. So app chains, as I mentioned, is a custom blockchain which lends security and decentralization from the main chain. So, but still it's your custom blockchain. You can define your configurations. It's completely within your control. You can define the gas fee, define your own token economics, etc. And then there are flavors within the app chain. So there are optimistic rollups, there are ZK rollups, and then ZK had limitation related to smart contracts. So now we have seen ZK EVM, like is one such example, which brings in the smart contract and the EVM capability to the ZK proofs. So you have ZK proofs, and ZK proof, cut down a lot of hassles. There's instant finality, and you're passing on the state to the main chain. So in terms of security and decentralization, you're relying on the parent chain. You're pushing the state there, so that way you do not have to bring in your own validators and work in that space. They are highly scalable. Again, these are custom chains. There's no sharing of resources. You have your own dedicated resources, starting with a small app chain infrastructure with 5-7 nodes, depending on which protocol we talk about. And then you can easily scale it up across different, adding more nodes and make it more scalable. And again, they are interoperable with the main chain. And then, Polygon Supernets has launched interoperability. Avalanche has also launched interoperability with other EVM chains. So the interoperability, quite a few mechanisms are already in place. Developer and partnership ecosystem again needs to be built. But since if you're launching Avalanche Subnet or Polygon Supernet, then in this case, the Polygon and the Avalanche and similarly DCOM, etc., they are going to help you popularize, in fact, participate in promoting you, and so on and so forth. So there's a ready ecosystem which can be very helpful. And then, of course, some more partners, etc., needs to be built on the end of the app chain itself. Examples being Polygon Supernets, Avalanche Subnets, DCOM Subnets, etc. And as I mentioned, now most of the other blockchain protocols, layer 1 and layer 2, are coming up with their own app chains. So this is, in summary, I hope in a limited time, I could give details about various considerations when you're building your own tokenization platform or launching a tokenization platform. From a scalability perspective, performance, more control, and interoperability and ecosystem perspective, making a right choice becomes very important while choosing or building your tokenization platform. Where Zeeve fits into the picture, we are one of the leading app chain infrastructure as a service platform. Today, we support all the major app chains and custom blockchains. With Zeeve, rather than going through manually, going through the learning curve and manually deploying the infrastructure and then managing and monitoring, we provide completely automated deployments of Polygon Supernets or Subnets or Cosmos or Substrate parachains, and with sophisticated analytics and monitoring dashboard to ensure that you don't need to worry about the underlying network, and you can simply focus on the dApp or the innovative venture that you are working on. So yeah, that's pretty much I wanted to cover. I'm happy to cover any questions if anyone wants to ask.
That was brilliant, Ravi. Great start to our conference. You have 2 minutes, so maybe 1 or 2 questions. If folks can post their questions real quick on the chat. And while we do that, just want to know that the next topic is related to mortgages, the state of the mortgage industry in tokenization. But before I bring up Marvin, we have 2 minutes, so any questions, this is your opportunity to ask Ravi. Ravi, someone messaged me asking, how is the throughput of a chain that is connected to the underlying infrastructure, right? How does that impact scalability?
Okay, so throughput, like basically how many transactions can be processed per second by a blockchain, right? So that is one consideration. So as we know, the transactions are packaged into a block. There's a specific block time. So a number of transactions can only be processed within that time frame. So that is one aspect. The second is how quickly the finality takes place. So even if you have done the transactions, you need to wait till the transaction achieves finality. That again, finality time varies from blockchain to blockchain. It may be 3 seconds, 1 second, 10 seconds, or even less than 1 second. So these are two different considerations that become important when you talk about scalability, because transaction throughput and performance, especially when the transaction volume increases, this becomes of paramount important.
Excellent.
I hope that answers your question.
Appreciate that. Folks, you can follow Ravi. He's a thought leader in the space. He speaks elaborately on different topics. We were excited to host him at a Hyperledger, virtual global meetup a few weeks ago. So you can follow him on social media stay connected with Ravi. Ravi, thank you so much. I know it's fairly late in India. It's almost 10 p.m. Really appreciate you joining us, and I'd love to see you come back in the future and speak.
No, thanks everyone for listening to this session. And as I always say, keep building, keep smiling. Thank you.
Take care, Ravi. I'll be in touch. Folks, I think we had a good start. Now we will change gears. We took one technical problem, and we spoke about scalability. Now we'll switch gears more towards the business side of things. I want a Token Expo to be geared more towards the business audience. There's a lot of technical content out there, but not a whole lot about, talk about real use cases, right? And some of the key areas of, tokenization in real estate, in capital markets, in energy trading. We are not covering professional sports in today's edition, but in the near future, I would like to cover professional sports. I'm a huge sports fanatic. I think there's a lot going on with blockchain in improving the fan experience, etc. But enough of that.